to learn how to solve modular arithmetic problems, we need to first know what does this expression even mean in the first place. Because when we know how to interpret this expression, we would be able to solve the numerous problems modular arithmetic can have against us. So, we have 4 interpretations that can help us solve these problems. Number 1, x and y have the same remainder when divided by n. Number 2, x, this one can be described in the expression x equals kn plus y, where k is a proportional integer. When we say proportional integer, integer meaning that the value of k cannot be a decimal. So, if k is a decimal, then this is not a equivalent to this expression. Next, number 3. So, by this expression, x and y are multiples of n. So in this expression, x and y are multiples of n. And last, we can expound this expression. It's the same one. We can expound this expression into x mod n is equal, not congruent, equal to y mod n. So, in modular arithmetic, we have the first type of problem, the verification problem, where it's all we need to do is to verify if this expression is congruent. In order to know if it's finding congruency is by this symbol, an equal sign with a curve on top of it. So, let's practice. So the first question is 27 is congruent to 2 modular 5. So, how do we solve this? If we can go back to the interpretation for this one, let's go to number 2. It says here that this expression, as this is equivalent, must have this expression where k is a proportional integer. So, if this follows the format, then all we need to do is just assign our variables and manipulate the formula of number 2. So, let's isolate k since we already have x and y. So we would have this formula. K equals x minus y over n. So, and then we substitute the formulas. We assign x as 27, y as 2, and n as 5. So, when we put those in a calculator, we will get an answer of 5. And now, how do we know if this expression is actually congruent? Simply put, as we can go back to the definition of k, proportional integer, integer whole number. So if the value of k is a whole number and not a decimal, then the expression is congruent. That's it. That's all you need to know. If k is a whole number, it is congruent. If it is not congruent. So let's have number 2. 19 is congruent to 4 mod 7. Is this true? So we substitute the same formula with with different variables, x as 19, y as 4, and n as 7. We substitute the values and we'll have a result of 2.14. This value of k is a decimal. Therefore, the result of this expression is not congruent. So that's how you verify modular arithmetic expressions. And now the next type of problem is evaluation. Evaluation meaning you have an expression but there's a missing variable within it. And you need to find that expression, we need to find that value or variable that will make this expression valid. So, if we keep on following the same format or the same formula and the same process, we would still have the same result, but with a different twist and a technique. So, still, it has the same format as k, even though it has 2 mod 9. Remember, number 4 evaluates this expression as simply this one. So, no need to panic. We just need to return this form back into its original place. So, this means that on the left side, this is x, and on the right side, this is y. So, how do we solve this? Simply put, k equals x minus y over n. So, substitute, 15 plus 18 is x. Let's say y is the question mark, so we put that as x. Don't be confused. That's why I put a different colored x in here. N over n, which is 9. So, how do we know, or how do we find the value of x that will make this one valid? Remember, from the definition, k is a proportional integer. It cannot be a decimal. It must be a whole number. So, we need to find values of x that will make this expression a whole number. And therefore, we would have a table of values. So, if we assign values of x in a consecutive manner, such as 4, 5, 6, 7, for example, and if you input x into this expression, you will have the values of k. And k would be as follows: 3.2, 3.1, 3, and 2.8. The only whole number in this table of values is 3. And that is when x equals 6. So that means our x value, in order to make this expression valid, is 6. Therefore, the final answer is 15 plus 18 mod 9 is congruent to 6 mod 9. Next, 13 times 22 mod 6 is congruent to an unknown number mod 6. Still the same format, still the same process, still the same table. So, k equals x minus y over n, k equals x, 13 times 22, minus y, or x, black x, over 6, which is our n. Then, find values of x that will make k into a whole number. Use the table. 4, 5, I chose the consecutive numbers 4, 5, 6, 7. So, when I input 4, I get 47. 5, 46.7. 6, 46.7. And 7, 46.5. So, only 4 gave a whole number result of k. Therefore, our x value that will make this expression valid is 4. Therefore, the final answer is 13 times 22 mod 6 is congruent to 6 mod 6.